We're going to finish up section 4.1 with an application of antiderivatives. And this will also give us a reason to understand why it's important to remember the plus c when we find antiderivatives. I'm going to introduce this in the context of an example from the book. This is problem number 38. And it gives you two pieces of information. It asks you to find a function g such that, to begin with, the derivative of g is equal to 4x squared, and also g of negative 1 is equal to 3. So this is what's known as an initial value problem. An initial value problem has two parts. In one part, it gives you information about the derivative or derivatives of g. That's called the differential equation. And it also gives you one or more specific values for the function. And those are called initial conditions. As a rule of thumb, if it tells you the first derivative of g, then it's going to give you one initial condition. After this problem, we'll do another where we have a second derivative and we have two initial conditions. So here are the steps in solving an initial value problem. The first step is to find the general solution by taking the antiderivative of g prime here. So the function we're looking for, g, will be an antiderivative of g prime of x. In other words, an antiderivative of 4x squared. Take the antiderivative as usual, we get 4/3 x cubed plus c. The next step is to find out what specific value of c will make g of negative 1 equal to 3. So step 2, we find what value of c gives g of negative 1 equal to 3. So we're using the initial conditions to find c. So we know that g of negative 1 from step 1 is going to be 4/3 of negative 1 cubed plus c. But we also know that g of negative 1 has to equal 3. So we can set this equal to 3. Let's simplify. Negative 1 cubed is negative 1. So negative 4/3 plus c equals 3. And then we can add 4/3 to both sides. Notice that 3 plus 4/3 is the same as 9/3 plus 4/3, which is 13/3. And then finally, for step 3, we're going to plug c back into the general solution. So over here in the general solution, we have 4/3 x cubed plus c. But where I had a c, I replaced that with 13/3. And that's the solution to the initial value problem. For a second example, let's look at problem number 42. Here they tell us that f double prime of x is equal to 3x squared, that f prime of negative 1 is negative 2, and that f of 2 is equal to 3. So this first expression is our differential equation. I'll write dE for that. And both of these specific values for f and for f prime are initial conditions. So I'll think about this as being IC for initial conditions. So what we'll do is we're going to integrate f double prime to find f prime, and then use the fact that f prime of -1 equals -2 to find out what the first derivative of f is, and then we'll integrate a second time to recover f. Let's do it step by step. Since f double prime is 3x squared, we know that f prime of x is going to be the antiderivative of f double prime of x. In other words, the antiderivative of 3x squared. Well, an antiderivative of 3x squared is going to be x cubed, and then I add c. In step 2, we're going to figure out what c is so that f prime of -1 equals -2. So we're given that f prime of -1 equals -2. So let's substitute -1 in for x. F prime of -1 is -1 cubed plus c. And we're going to set that equal to -2. I'll squeeze the solution in over here. -1 cubed is -1 plus c equals -2. So c is -1. So step 3, I'm going to take that value of c and plug it back into the general solution here. So f prime of x is x cubed minus 1. Notice that I've replaced this c with -1. And now we're going to cycle through all of this again. Now we know that the derivative of f is x cubed minus 1, and we still have this unused initial condition that f of 2 equals 3. So continuing, let's go back to step 1 again. I'll call it step 1 prime, second time through. The function we're looking for will be the antiderivative of f prime, which is the antiderivative of x cubed minus 1. Using the power rule, I get 1/4 x to the 4th minus x plus c. To figure out what this c is, I'll use the initial condition that f of 2 equals 3. So substituting 2 into this antiderivative, I have that f of 2 is 1/4 times 2 to the 4th minus 2 plus c, and I'll set that equal to 3. So 2 to the 4th is 16 over 4 is 4. So 4 minus 2 plus c is 3. So 2 plus c is 3. So that tells me that c is equal to +1 this time around. And then finally, last step, I take this c equals 1 and I plug it back into my expression for f. F of x is 1/4 x to the 4th minus x plus 1.